Hello everyone, welcome back to our channel. So today we are looking into LeetCode Problem 236. Here it is lowest common ancestor of a binary. So what is lowest common ancestor? So let's take 5 and 1. So we can say the lowest common ancestor is nothing but which node is close to this both nodes, and it should be that node should be parent also. So when coming to the first example given, here we are given a binary tree and two nodes, that is 5 and 1, and we can see that 3 is ancestor for 5 and 3 is a ancestor for 1 also. So we can see 3 is the lowest common ancestor for both 5 and 1, and we have some condition also that one element that can be ancestor to itself also. Let's say if we are given 1 and 8, 1 and 8 as the nodes, and we need to find the common ancestor for it. We can say that one is uh, one is also a ancestor to 8, and we can consider one is ancestor to itself also. So the lowest common will be 1 itself. We can see the same example in example 2. So here we are given an uh, P array, and here the P is 5, that means the first node is 5 and the second node is 4. Here you can see 5 and 4, and 5 is, we can say 5 is ancestor to itself and 5 is ancestor to 4 also. So the common ancestor for both of them is 5 only. So we can't say 2 is ancestor for 5 because it is a child of 5, right? So we can say only 5 is ancestor for 5, and for 5 is also ancestor to 4. That is example 2. And we are given a simple one where we have 1 and 2. That means we have 1 and there is nothing. uh, Sorry, here we don't have anything. I'm denoting it with the hyphens, and here we have 2. Okay, the left value is nothing but empty, and here we have 2, and with the given values are 1 and 2. So 1 is itself an ancestor to itself, and 2 for 2 1 is ancestor, so we can say the lowest common ancestor is 1. To solve this issue, we are going to follow recursive method. So what is our recursive method? So here, let's say take this example. What we need to do is, so the given tree node P and Q, we we are very sure that either it should be part of left part of this node, that means all the left child or the right child. So what we are going to do is, we are going to check where we have this 5. So after finding 5, what we can say is, let's say I'm starting from here. So I'm checking in the left part of the binary array for P. That means the tree node P. So let's say I found this 5, and now what I need to do is, I need to check the left part of this array. If I find the Q in this particular array, then I can say 3 is the lowest common ancestor. Okay, let's assume that we didn't find Q in this particular part of the array. Then we can move to the right part of the array and we can check further. Let's say we are given 5 and 2. 5 is as a P and 2 is as a Q. So what we are going to do, first we are going to check in the left part of the array for 5. Yes, we found it, and we will check the right part of the array for 2. Here we don't find it. Then we will check the 2 in left part of the array and we find it. Once we find it, we can say that, so either 5, we can say that 5 is the common ancestor. So we will get more clarification while we are writing the code. So let's directly jump into it. So what I'm going to do is, I'm going to check my my P and Q both. I'm checking P and Q both in left part of the array. Okay, I'm passing these two parameters, and the same with right also. So what I'm going to do, I'm checking P and Q in the right part of the array. So once I have the result, so let's say I am going to have some result. Okay, if left is not equals to null and right is equals to null, that means we got some values. We found P in left part of the array and Q in the right part of the array. That means we can say that root is the, that means root is the root is the lowest common ancestor for this. If we didn't find, if we didn't find in the right part of the array or left part of the array, that means both values will be hidden in the either one of the side. That means I can return left or right. Any one of them which are not null will be returned. And what is the base condition? We are calling uh, our recursion method, right? So what is the base condition? Base condition, I think that is, but if root is equals to null or root is equals to p, that means we found p, or if we found q in one of the condition, what I can say is I can return root. Okay, that's it. This is our solution. This is very simple, straightforward. Yes, so it's succeeded in base conditions. Let me submit it. Yes, it's working fine. It's not very automated as it is a recursive one. We are making so much of calls to the functions. We are making each time we are making two calls to the function, same function, and you can see we are having so many calls. That means that's why it is a very it is not very automated, but it is a good way to solve this issue. So that's it for today. Thanks.